In this lecture, I'll talk about diffusion models, which are the most common current form of AI text-to-image generation right now. I'll discuss some of the history of how they emerged, some of the kinds of images that they have troubles with, as well as some current concerns for them, but I won't have time to go into too much detail of how they work or even about any of these issues. Okay, so in March of 2023, a now famous AI-generated picture of Pope Francis wearing a puffy jacket went viral, and many people were inspired to produce various responses to it. Either this or a few other images around the same time were the moment at which AI image generation became extremely well known to the general public. However, it was actually the year before, in 2022, that AI image generation, text to image, first became easily accessible by the general public. OpenAI's system DALL-E 2 was released to a few testers in April, and then a million or so in July, and made fully open to everyone in September. The competitor Midjourney made its version 2 model open to the general public in July, and quickly soon after the version 3, and Stability AI released its open source model, Stable Diffusion, in August of that year. This was all a few months before the conversational large language model, ChatGPT, based on GPT 3.5, went public, which itself brought massive additional attention to generative AI. Now, the fact that these were version 2 of DALL-E and Midjourney shows that these models had actually been in development somewhat earlier than 2022. But the history is surprisingly short. For both of them, version 1 was less than a year and a half before this. Interestingly, up until very recently, AI was primarily imagined either as a tool for classifying things or making recommendations or doing some sort of interactive behavior. The idea that an AI would be used to generate an image or another cultural product like a text wasn't really how people were thinking. So throughout most of the history of artificial intelligence, people have been thinking in terms of computers processing information, identifying things, making recommendations, not so much making works of art. Early computer graphics in the 1980s and 90s was not usually thought of as part of artificial intelligence. It was instead developed as tools for working artists, and it gained prominence in films like The Abyss, Terminator 2, Jurassic Park, where CGI was replacing special effects that had been done in practical effects on the set. And then finally, Toy Story in 1995 was the first full-length computer-generated film. But in all these cases, the computer wasn't really generating the image, it was working on behalf of humans. These were very different from modern text-to-image tools. And we wouldn't say that the computer generated the art, it was involved in the generation process. Instead, the modern text-to-image systems derived from a very different strand of work that was going on earlier in the 20th century in image classification and identification. And this is really the history of computer vision and image processing in artificial intelligence, which goes all the way back to the beginning of the field in the 1950s and 1960s. Much of the early work was very ambitious before it was clear just how hard the problems would be. Symbolic approaches dominated, and in the 1970s, they were able to get to the point that they could control some robots that would move around a room and do things like automatically detect edges and figure out what sorts of objects are present from a very narrow range. In the 1980s, this work was continued, but there were advances in processing power, and with the rise of the backpropagation algorithm, neural nets became a lot more prominent. And in particular, in 1989, Jan LeCun built the first practically valuable neural net, which helped the post office automatically recognize handwritten digits in zip codes. In the 1990s, there was work in both symbolic and neural paradigms about trying to automatically identify where faces are in images, trying to distill faces down to a set of features that could be symbolically recognized. And eventually in the 2000s, this was extended to other kinds of objects than faces that have parts that can change shape if you look from different angles or if the object moves. But Much of the really important work in the 90s and 2000s was the generation of tidy labeled data sets, like the database MNIST that Jan LeCun drew up of 60,000 legible handwritten digits, clearly labeled, so that further people could train their own neural nets on them. And then in the 2000s, Fei-Fei Li at Stanford generated this set called ImageNet, which had 1 million different images that had been labeled by humans at a variety of levels of specificity and generality. Uh, and then with these data sets, researchers were able to generate really powerful neural nets. And one of the major breakthroughs was in 2012 when Jeff Hinton, Ilya Sutskever, and Alex Krzyzewski built this system AlexNet, which showed that neural nets were much superior to all the other approaches yet developed. This was for the ImageNet database. It was getting 85% of the images with their correct label, which, considering that there were thousands of labels possible, is really quite impressive. Now, since these neural net models were much less understandable than the kinds of symbolic models that had been dominant before, one interesting project a lot of people were working on in the early 2010s was trying to figure out what each neuron in the neural net was doing. In these classification neural nets, one interesting project that Alex Mordvintsev at Google did was to think, let's take a neural net that goes from an image to a classification and try to understand one of the neurons in the middle by seeing what change to the image would make that neuron fire better. And so here we have an example of this in this project that he called Deep Dream because of the dreamlike and hallucinogenic images that it was able to generate. That each of these images here started with the Mona Lisa, went through this ImageNet neural network, and then focuses on a different neuron inside to see what changes to the image would enhance that neuron. And we can see that some of these neurons seem to be doing relatively simple things like detecting edges. Some of them seem to be detecting eyes or other more complex abstract ideas. It's hard to interpret exactly what's going on with any of these neurons, but this idea to try to interpret the neurons was thought-provoking. And importantly, it also showed that both higher level and lower level features of an image might be controlled by an AI. Now, over these next few years, there were several other important developments that are beyond the technical details I'll be able to have time to go through here. There were these things called generative adversarial networks, where you train two neural nets simultaneously. One of them tries to classify images, and the other one tries to generate images that will fool the classifier. And since these two neural nets are in an arms race with each other, each is able to get better than they would alone. And this turned out to be valuable for generating lots of images. And then there was this UNet that was developed first as a way to downscale an image and then scale it back up in a way to identify large-scale features of the image. But then when this was connected to the development of the transformer in language processing, they were able to take a text, compress that into some sort of meaningful representation in the computer, feed that into the UNet so that when the image gets scaled back up, it now involves this meaning of the text. And they were able to use this to put together some of the first diffusion models in 2021. Now, the first generation of these diffusion models was clearly quite restricted and also at the same time clearly very powerful. In 2022, when DALL-E 2 was announced and there were some demonstrations going on showing some of its power, I found a site where I could use DALL-E Mini, which was a version of the software from 2021. And I just tried these examples. I typed in various addresses and wrote for sale. And now these images from this early 2021 diffusion model would never be mistaken for photographs. Even at this zoom level, they're clearly distorted in various ways. But at the same time, it's also clear that somehow these early models were already tapping into deep aspects of style. If you look at houses on 47th Street, the AI seems to think they will be in a traditional 19th or 20th century American style, architectural style. If it looks at addresses on San Vicente Drive, it seems to show a 1960s California suburb. On Rue de Chopin, it seems to show interiors of a classy French apartment. And then soon after, in late 2022, people were using these to generate all sorts of very impressive images. I found these on a Tumblr from just July of that year. Stoner Jesus giving a peace sign, an anime steampunk engineer, a K-pop bodhisattva, Cleopatra using an ATM. But one thing many people noticed was that even though these images are very impressive at some level, when you zoom in on the hands, there's something a little bit weird. There's either extra fingers, or the fingers have merged together, or they're bending in ways that are completely unrealistic, even if the image style is supposed to look like a photograph or an art style where the fingers would usually be realistic. And similar images showed up if people were using the image to draw text or a diagram. It gives really good attempts at hobbits in a 16-bit video game, or a baseball team with an animal as a mascot, or a Simpsons-themed breakfast cereal, or the alphabet in calligraphy. But if you look at the actual text, it's badly misspelled. And when there's a lot of it and it's smaller, it often doesn't even quite look like letters at all. Look at the Q in that alphabet that's maybe a G, or the W that's maybe a U. These examples that I've shown so far are all from DALL-E 2 in June of 2022, but its competitor Midjourney had similar issues. So here's some images from December of that year where someone was looking for an ugly Christmas sweater or a box of Twinkies next to a stethoscope. Uh, these images may be higher quality than those from DALL-E, but they still had issues with numbers of fingers and with what the text looks like and how the words are spelled, even if the word was in the prompt. Why might this be? Why have hands and text been particularly bad issues? And the general issue is that the AI is just trained on a large amount of data, just a bunch of images of all different sorts. While we humans care particularly specially about human body parts and text, the AI doesn't really treat that as anything more or less special than any other sort of image that it looks like. And the human visual system, maybe we're very attuned to problems with text or with human hands. With other sorts of objects, maybe we're a bit more willing to see things in weird ways. And think about how your visual system deals with this particular impossible shape, which is sometimes called a blivet. This looks weird, but maybe not quite as bad as those AI hands. And you can see this with text and with body parts for other animals, that most of us will recognize very fundamental issues that are going on in our native language. But if you speak English or you speak Chinese, you'll very clearly recognize many things wrong with the text on those objects. But many people who don't speak English or who don't speak Chinese still think that English words or Chinese words are somehow interesting or fun to have on their tattoos or their clothing. And so they'll put something that looks like English or Chinese text to them, but doesn't really work. And the same thing happened when we draw animals that we're not familiar with. So on the left, we have the very first painting by a European of a kangaroo from 1770 compared to an actual photograph of one. And you can tell that that European painter was painting the kangaroo as though it was actually a mouse or a deer or some other animal that he was familiar with, rather than getting the shapes of a kangaroo right. And to the AI, that's what humans are. We're just some animal that shows up in its pictures, and it gets the details roughly right as far as it can tell. But to us, who really care about our own language and our own hands, these look really bad. Now, another issue is that these image generators are neural nets. these diffusion models, they're neural nets. They're not symbolic systems. And so they're much better at getting impressions and patterns rather than things like counting or getting diagrams right. And so here's an example of some real estate diagrams that Midjourney drew in 2022 for a two-bedroom apartment. If you know how to look at a real estate diagram, you see that these make no sense at all, even though they sort of capture the feel of what an architectural diagram might look like out of the corner of your eye. But if you're looking for rooms and doors and bedrooms and bathrooms and so on, you immediately see that it's wrong. Uh, and counting is the sort of thing that takes a symbolic system, and these neural nets don't have that built in. So if you were to imagine something like a house with a picket fence, you can probably visualize the pattern of the fence posts, but you wouldn't have a precise count of them. It's only for a few things like human hands, where we're very familiar with exactly how many fingers are supposed to be on it, that we will have that sort of count in our imagination. And now another point that I think is very important is just what does the training data look like? So look at these photographs of someone teaching some kids how to tie knots or someone reading at a park bench. These photographs, which might be in the training data for the image generators, have just a very small bit of the field of vision that includes people's hands or includes people's text. And there is hands and text in both of those images. But the people who are actually doing this, to them, they're looking at their hands, and their hands are making up a large part of their field of view. And the text might be what they're looking at too. So that's a large part of their field of view. Uh, since the hands and the text aren't very often in photographs, they don't generally make up the majority of a photograph, but they do make up the majority of some parts of our daily life in our visual field. So we are much better trained at identifying text and hands than the AI is. And of course, human artists have also known for ages that drawing hands is remarkably difficult. People are very harsh critics if you get hands wrong. And so this is one of the very important sections of an art class, is just practicing actually looking at a hand and seeing what it looks like to draw it. And now these last couple points are ones that have been heavily addressed in newer models. The new version of text-to-image generators have all been trained on a lot more photos of hands, as well as many other things. And so the images that they're producing in 2024 are much improved in general realism, in artistic style, also in specific things like what hands look like. But many of the symbolic issues are still difficult, both the text in terms of getting spelling meaningful, or even producing things that are always letters, and in things like an architectural diagram. If you look, these architectural diagrams on the right are all better than the ones on the left, but if you look at the pathway from the kitchen to the dining room, you'll realize that these are not real apartment diagrams. I think at least one of them doesn't even have a kitchen, and for the others, the dining room is not located in a place where a human would put it. Now, I'll close with just a few minutes of discussion of many of the major worries that people currently have about these text-to-image generators. Probably the biggest worry is a pair of related legal and moral issues about ownership of the products of AI image generation. Many of the most useful prompts that people have found in generating images involve giving the name of an artist to imitate. Do this in the style of Pablo Picasso, or in the style of Ansel Adams, or in the style of Georgia O'Keeffe. There's both a legal question of whether it's legal for the companies to be training on copyrighted images. Now, many of those artists I've mentioned are out of copyright now, but they're training on copyright images and using them to produce work for commercial profit. There's a question of whether that sort of use of the copyrighted image is legal. And there's furthermore a moral question of whether the artists deserve compensation for this unforeseen use of their labor in defining a distinctive style, even if it's not legally binding. Now, we've seen many of these issues already with human-produced art. So, for instance, here's this famous poster that the artist Shepard Fairey made for Barack Obama's presidential campaign in 2008. And here's a very cheap imitation of this that some user named Ed Christian 2 is selling on Redbubble. Obviously, the new image is derivative of the old one. And in fact, no one would want to even buy a poster with this cat and this color scheme that says nope, except because of the original one being so famous. Now, uh, it may not be that Ed Christian owes Shepard Fairey any sort of royalties for this, but there's some sort of moral dependence here, and it's hard to work out exactly what we should think about that. Now, one thing that's a bit less well known is the fact that Shepard Fairey's poster was itself derived from a specific photo of Barack Obama that was taken by the photographer Manny Garcia for the Associated Press in 2006. Manny Garcia was never compensated by Shepard Fairey for the use of this image or by the Obama campaign, let alone by any of the people that copied Shepard Fairey's image. But it's also worth noting that Manny Garcia has been a highly recognized and compensated photojournalist. He's won many major awards and for his work over many decades, including a military airplane disaster in 1989 and a photograph of George W. Bush from 2005. Now, I could very easily probably do a whole multi-hour video essay about the analogies and disanalogies between various legal and moral issues for human art, like satire, adaptation, inspiration, appropriation, and the parallel issues for AI art trained on human images. But I won't have time to go into any of those details here. Now, a separate issue that some people have had is just thinking about the kind of technological job loss that artists and graphic designers might have now that it's so easy for other people to generate images of this sort. This is perhaps a more acute version of a worry that many people have about the use of AI in the broader economy generally. Now, a more distinctive worry about AI-generated images, and AI-generated text for that matter, that is distinct from many of the other worries about AI, is that these things might be able to flood the internet with mediocre work, what some people have called AI slop, that would drive out actually good work by creative individuals. And this is very related to the kind of worry that many people have about things like social media, where we fill our lives with mediocre, technologically mediated relationships with people on the internet in ways that stop us from spending time with other people who we care about in person in ways that we value, in ways that we can't get online. It's hard to know how different these worries are and how significant either one is, because it's true that there's value in having the additional relationships that social media allows, even if those individual relationships are each less valuable than the in-person relationships that we have with our friends in person. Uh, and similarly, there's something to be asked about, will the AI slop that fills the internet, does it provide some value that in its quantity might make up for the loss of quality? This is certainly what most of us think about the fact that those of us alive today hear a lot more music and see a lot more visual art than people a century and a half ago did, even though we now probably see less of that in person, and most of it is just mediated through a screen or headphones. Now, one final worry as I record this in August 2024, there's a lot of worries that we might be in the middle of a tech bubble, that companies have been pouring tens or hundreds of billions of dollars into training the more and more powerful versions of these generative AIs, and they haven't yet identified real economic value that is commensurate with the costs of what they're spending. That there is real value in generating text and generating images. It's just not clear that it's yet going to be able to make up for the tens or hundreds of billions of dollars that they spent designing it. It could well lead to a boom and bust cycle, much like the early internet boom in the late 1990s involved companies investing in huge amounts of telecommunications cables that people weren't able to make use of. Though a decade or two later, that infrastructure investment turned out to be extremely valuable. Same thing happened with the railroads in the 1870s, that there were several boom and bust cycles when companies invested so much in building this expensive infrastructure that then didn't really get taken advantage of. But then, multiple decades later, it was valuable to have that in the background. At this point, diffusion models have only been providing text-to-image generative AI for about 3 years, and they've made massive improvements in this period, but still have some major limitations. It may turn out that diffusion models are replaced by some other paradigm in the next few years, the way that diffusion models replaced the generative adversarial networks of a few years earlier, and the way that all of these neural net products superseded the symbolic AI in the past decade or two. Or it may be that the current generation of neural AIs really do mark a major transition, enough of an advance over predecessors that the bitter lesson applies, that more scaling, more training data, more computing power might be all we need for this to do everything. No one knows yet.